Defining production decline in well drillings. Another key variable for production estimation is the assumed decline factor. Decline curve analysis is a graphical procedure used for analyzing declining production rates and forecasting future performance of oil and gas wells. Oil and gas production rates decline as a function of time, loss of reservoir pressure, or changing relative volumes of the produced fluids, are usually the cause. We will use here the simplest model, which is the exponential one. According to Arps, who originally defined this methodology, this model is the most common one. Under conditions such as constant well back pressure, an exponential decline assumption behaves relatively well. The exponential model assumes a constant rate of decline with respect to the previous period. In this sense, since we are applying a constant rate of declining production with respect to an increasingly diminished base, an exponential curve rises a long time. In this example, we assume that, according to experts' opinion, the monthly exponential decline rate has a minimum value of 1.5%, a most likely value of 2.0% and a maximum value of 2.5%. 14. Insert on the range before D4, the following parameters that we will later use for a PERT distribution for exponential decline rate, 1.5%, 2% and 2.5% respectively. The oil company is planning on drilling 5 commercial wells per year during the first 5 years for a total of 25 operating wells. However, the fact that a well is drilled does not guarantee that it will eventually become commercially feasible. In fact, historic drilling information in the region states that the probability of success of effectively drilling a well is of 70%. The question here is, probabilistically, how many wells have to be drilled in order to eventually end up with 5 operating wells, given the fact that the probability of success is of 70%. There is a specific distribution function that exactly answers that question, the negative binomial distribution, or risk-neg-bin and at-risk. A risk-neg-bin, S, P, function specifies a negative binomial distribution with parameters S and P. This distribution is typically used to model the number of failures before achieving S successes in independent, identical trials, each with probability P of success. 15. On cell H6, write the assumed probability, based on previous regional history, that a well might become commercial, 70%. 16. On each cell of range B11:F11 write a 5, as this is the number of wells that are required to be successful by the end of each year. 17. Place your cursor on cell B12 and click on Risks Define Distribution icon. Go to the Discrete tab and double-click to select the neg-bin distribution. The following distribution appears. 18. Click on the Assign Excel References as Arguments button and click to select S as cell B11 and P, the probability of success, as cell H6. 19. Return by clicking on the upper right-hand corner of this window to the distributions chart. Given that you need 5 successes, drilled commercial wells on any year, and that the probability of success of 70% of drilling any well, there exists a 17% probability that no more than the 5 will have to be drilled. By placing the left-hand delimiter between the 0 and the 1, and the right-hand delimiter between the 1 and the 2, you could read a probability of 25%. This means that you will need to drill 6 wells, 5 plus 1 additional, in 25% of the probable cases. There is, in fact, a 58% probability that you will need to drill 7 wells or more in order to end up with 5 successful wells per year. There is also a 10% probability that 10 or more wells will have to be drilled in order to allow for 5 operating wells. 20. Click OK to close the window. 21. Edit the cell with F2, in order to add up plus B11 to the formula. Therefore, the formula should now look like this. Equal risk neg-bin, open parenthesis, B11, comma, P success drill, close parenthesis, plus B11. We need to add B11, containing a 5, because neg-bin calculates the number of failures before a certain target value S is achieved. Therefore we add the number of failures, which could be 0, additional to the 5 commercial wells required per year. 22. Copy cell B12 and paste it to the range B12:F12 for the first 5 years of investing on the field. 23. On cell V12, write the following function to totalize the number of wells that will have to be drilled in order to have 25 operating wells, with the formula, sum B12:F12. 24. To start accumulating total commercial wells, on cell B13 write the following reference formula, equals B11. 25. On cell C13, write the following accumulating formula, equals B13 plus C11. 26. Copy this cell C13 and paste it to the range C13:U13 for the range of 20 years.